Hey, what's up?
Hey Brian, how's it going?
It's going all right. How's your day?
All right. I think I have a wisdom tooth coming in, so my mouth's been killing me.
Oh, that sucks.
Yeah, I'm not having fun with that one. How have you been?
Good. Just busy.
I saw you running around some electrical stuff on Discord. That's pretty cool.
Oh yeah. Yep. I have a midterm tomorrow, so I'm just
So you're in
trying
school
to.
right now.
Yeah, I'm taking a chemistry class.
Dang, okay. You're doing a lot. All right.
Mm.
Hoping more people join. I know Holland can't make this today because she's going to the beach or something like that, or going camping. I think it was.
Mm.
But my main thing I wanted to do today was just go over again basically what you talked to us about on Friday in a little bit more detail and hopefully give me a better idea on how I can start designing stuff right now for next class. I'd like to have a basic design done before next meeting.
Yeah, I was actually thinking about attending the workshop for mobility that mobility is hosting.
Mm-hmm.
And just maybe talking to Ivan or whoever's holding it and seeing if they can help out just during the workshop. But I don't
What's
know.
the workshop?
It's like a SolidWorks workshop for I don't know what they're covering, but
Okay.
yeah. So I'm not like I don't know if I mentioned this, but I just basically recently learned how to use SolidWorks, and it's super cool. It's way easier than I mean, it's not easy, but it's easier than I thought it'd be. So I had like a class during the first session of summer
Mm-hmm.
where we had to make a thing. So I was like, all right, well, my girlfriend has a 3D printer. I guess I can like try to make something and learned some things, but in no way am I skillful.
Yeah, got you.
But yeah, if you want, I can go ahead and start talking about it now. Maybe we can wait a little bit.
Yeah, I mean, I am recording, so I can always just post a recording later for everyone to watch.
Okay.
But if you want to start now, that's totally cool.
All right. I'll just get ready then.
Are you going to be reading off of the same PowerPoint that you made last time?
Yeah, there's a PDF I actually updated
That's what I meant, yeah.
yesterday. Yeah, so I'll be going over that. Um, I mean, I can pull up SolidWorks, but I'm not sure if that's necessary. I think it's pretty straightforward.
Yeah, SolidWorks part won't be too hard to do. It's just getting an idea on what we're doing with the SolidWorks.
Yeah. I think I need host permission to share.
I'm sorry, give me 1 second. I'm trying to download your thing into OneNote.
Sure.
There we go. You should have access now with
Okay.
that. And J5 rotation and interference.
Okay, so I think you see it now, right?
Yeah, I see it. Just give me
Okay.
1 second before you start. I'm trying to set my stuff up as well.
Yeah, no worries.
Sweet. I'm all set whenever you are.
Okay. All right, just a second. Okay. I guess I could. All right. Cool. So move this thing out of the way. Okay, so this is just, I'm just going to be talking about um, the results of, I guess, the study, if you want to call it that, of the kind of cocking of the wrist. It's supposed to be straight up, and it's kind of cocked, kind of cantering. So basically, the wrist was not straight, and the reason it was not straight might actually be a couple reasons, but I'll go through this kind of quickly. So basically, I went over to Roberts, and the wrist was already removed from the actual robotic arm. So all I really had to do was take apart like the pins, some screws, like the C clips on the pins and stuff. So that's what I did. This is just an image actually at the very end. I realized I didn't take a picture or pictures before I disassembled it, but I ended up just taking pictures at the very end and just putting that there just so that we know what it's looking like. So this is it. Here are the pins being removed, just the little C clips with the screwdriver. And then I went ahead and measured some of these parts just to check for accuracy, you know, how far it is, how close it is from the SolidWorks design. And then, so those are all just measurements. Here I'm highlighting some of the things that are the problem. This is one of the parts that needs to be redesigned. This has the ring gear on it, and this part, what's happening is the ceiling where you can see I'm circling here. It's touching this mount, this thrust bearing mount, and that is obviously going to cause a problem in terms of interference. So that's just the ceiling I'm pointing at here. I'm measuring the thickness of it because I'm wondering if we can make that thinner. That would be an easy thing to do in SolidWorks, but it's really thin already. So maybe what we might have to do for the redesign on this is pull this out, pull the bottom, the face of where the ring gear is, pull it out, extrude it out, and then cut this other face off like a little bit by however much you pull it out. It is, and in effect, raising the ceiling. So
Yeah.
in terms of redesign, that's what would be it.
And you're not worried. I don't know how you're how experienced you are with 3D printing, but you're not worried that using another material is going to be too flexible and mess up the gearing?
Well, in terms of like material, that I think it's definitely worth trying 100%.
Yeah.
I don't know. That's a good question. I would assume that other like other testing like simulating the like stress testing within SolidWorks would be a good idea. I know you can set like the material of the part that you're designing and then do like I don't know what it's called. It's not dimensional analysis, but it's like where you check where where you'd have stress points. And you can just, I don't know. Those gears are pretty easy to make. That's actually one thing that's pretty easy to make just using a toolbox. So
I have another question for you. Sorry if you hear my dog in the background.
Oh yeah, no worries.
Another question for you. How is that ring gear mounted on? Because if you make it, is it resting on the actual the bearing right there, and that's how it's mounted, or is there a mount behind it?
So is there no, okay, I think I know what you're asking, but basically, do you see this sleeve? this carbon fiber sleeve bolts on, or not, sorry, not the sleeve, the opposite part. Actually, in the pictures, it'd be better. You see where this is that part right here.
Okay, yeah.
And you see how there's a washer right there?
Mm-hmm.
There's another washer underneath in between. That's why there's divots, like, where'd it go? Where'd it go? That's
Okay,
why there's like little imprints of the washers. So there's washers on both sides.
mm-hmm.
So I would say redesign that because that's kind of hard to get in there to
Yeah,
assemble
that
it.
would be. You would have to redesign it because if we have less of an extrude, we're going to ruin those holes right there, anyways.
Well, that's what I'm saying. Like, it depends on where they made the base from. Because if they
Mm-hmm.
made the base from where that ring gear is, I would assume it'd be harder. But if the base is on the top, then it really would just be just extruding it out a little bit more. But I don't know. I really,
Extruding
it
it
just
out
depends.
less, right? Not more. You wanted to make it thinner, not longer, not thicker.
Right. Actually, yeah, you're right. You're right. But
Okay.
again, it depends. It depends how they made the part. Because another thing that I noticed that it's kind of interesting, they split this part. I don't know. There was a few things that I was wondering why they made it that way. And I'm
Mm-hmm.
sure there's a good reason, but I realized I just didn't know why. So I haven't actually looked at that part. I guess that would be the next step, actually just going over and opening that part up, just that part, and then, clicking on the different sketches to see what was done to make it. But it doesn't really seem like a hard part.
No, it'd be so easy to manipulate that right now.
Mhm.
I
Yeah,
think I
so
might need to make it a point to get myself and hopefully a few more people to actually go to Roberts and look at it again so we can see in person what you've already seen.
yeah, that's actually a good point because there were several things that I would have never realized, like the
Mhm.
washer thing. Like, dude, that should be a redesign simply because that's annoying. Like,
Yeah.
nobody wants to have to line it up with like a pick, and
hmm
it's
That's
it's
how the
not a good.
whole robotic arm is.
Yeah,
Properly.
yeah. The worst part. Well, we'll get to it. So anyway, so that's probably the first thing that should be done. I laid it out in kind of a like most important, um and then like least important, but really all of the things should be done. Well, so this is one of the set screws that I had to remove this black thing.
hmm Oh wait, I had
And
one more question. I'm sorry.
yeah.
Back up to the reindeer that you were talking about. Do you know if the actual gears were the correct thickness for the whatever gear pinion was attached to it, or could I make those thinner?
Okay, so you're talking about the ring gear or the spur?
The ring gear right there, the white gear. No, not the spur gear, the actual ring gear.
Okay, so
If
your
we want to
question
make
is,
that not as thick, could I make the actual gears themselves thinner, or should I just go with that back mounting section and make that thinner?
okay, so you're talking about like this thickness right here?
Yeah, yeah. No, no,
Yeah.
no. Here, am I able to like have control over your thing?
Oh
Yep.
yeah, go ahead. You should be able to. Let
I
me
have,
set you up with the thing and then I'll hit approve. So yeah, go ahead.
do I have like control? So this thickness right here. So so that's gear from there all the way across to right there. That thickness. Could I make that thinner, or should I keep?
Oh, I see what you're saying. I mean, you generally speaking, you want to like to be honest, I don't know. That's a good question. I would assume that this is deeper than the spur gear is high.
Okay.
But not only that, it looks like they ground this down because this actually is what interferes and probably is the reason these gears look so great. These gears, the little fins on this sprocket, are really, I mean, not too bad, you know, because it's like cocked, totally cocked. And I
Yeah.
think part of the reason it's not that as bad as it could have been is because this metal, it was kind of giving it a little bit of support so that before it ground, the little metal kind of kept that clearance. But really, really small detail like that, you can easily shave that down and then just make sure this thing is straight. And then you wouldn't have to worry about any of those things.
You're talking about shaving down the spur gear or shaving down?
The shaft, metal shaft.
Oh, the actual shaft. Oh, okay, yeah.
It's metal and it's not like aluminum. It's
Yeah,
like a
steel. It's the actual motor.
steel. Yeah. So it'll take a little effort, but not a big deal. I would take the spur off with that set screw and then file it down.
Yeah.
Maybe paint it right as it is right now, like mark it. There's like you just paint it with whatever you want, and then when you remove it, you'll know how far to go down.
Exactly. Okay.
Then the set screw, this is like a really big one because that's like free basically. You just need to put another set screw on the other side. It was missing. It was missing from the other
Yeah,
side
you
of
said
it.
that was like a little fix, a temporary fix that they did, right?
That no. This
Oh,
I think I don't know what the story behind this. It kind of does seem like it though. Now
yeah.
that I think about it, because it almost seems as if they heated it up and then pressed it through that. Because when I was putting it in, it literally feels like you're stripping it because it's not supposed to catch, but it catches through the printed part. And then finally, that threaded insert, it's like brass threaded insert on the other
Mhm.
side of this plastic, this thing, it looks like this. Then it finally catches that. And then it feels, with resistance, feels good. It feels like you're not stripping it. But the entire time that it passes through this plastic, it's not, it doesn't feel right. So to be honest, it wouldn't surprise me if this side, maybe just the insert was threaded or stripped rather.
Yeah, with the amount of force acting upon that, I'm sure that they're all stripped out.
The other one wasn't. This one wasn't. This one was fine.
The threads were all fine inside of it.
Yeah, everything was fine in there for sure.
Okay.
Yeah, but so anyway, so definitely first see if it's stripped or not, which is easy. Just take it apart and look at it. And then like you just removing this screw that's in there and then putting it on the other side and making sure it's fine. That's an easy way. And then just buy another one, or you probably already have one somewhere. But yeah, that definitely has to be done. That's like the easiest thing because that is supposed to prevent it from tipping. So big deal, but small fix, easy solution. Here I did measure kind of the height of that clearance between that sprocket and the part that's actually like rotating. The other part, the ring gear part, is not on here. That's the only reason I can measure it, if that makes sense.
Mm-hmm.
Anyway, that's really small. I don't know if later that might give us trouble or whatever, but it just seemed like kind of scary. This is the same height right here. It's about 0.145 in American in inches. So anyway, this is the real big reason that I took some measurements. Like this is the whole point of the study, which is to figure out why this guy isn't doing its job. So to set this height, we obviously want to move this part, this black part, we want to move it forward so that this metal thrust bearing here actually supports this black part right here.
Sandwich. Okay.
That's sandwiched in between. Yeah, because it's not supposed to be sagging the way it is. See, there's a gap over here and it's sticking out over here. It's because it's not centered and it's pretty obvious. And it's actually way clearer in Adam's report. Yeah. What Adam did is he fixed this part. You see this bearing right here? That's a radial bearing. That bearing is being supported by 4 Allen screws that look like this. And you know, these 2 screws are two these 2 screw holes, these 2 holes here. There's 2 more over here, and there's 4 others on the opposite side. Those were done by Adam, like obviously on accident. Because I'm assuming he was trying to find the right height, and he realized it's much more difficult than just eyeballing a hole into it. The easy solution would be to put like washers, like spacers basically. And then if the spacer would not pushed, but if the spacer went around this head, and we'll say the spacer is we'll say 2 millimeters in diameter bigger, so larger diameter. That'll, 2 divided by 1, or 2 divided by 2 is 1, so 1 millimeter height increase. So it would essentially push this black part up so that it sits up higher, and then it actually sandwiches this guy.
Yeah. Putting a spacer on the head of the screw kind of sounds rigged to me, kind of janky.
Oh yeah, for sure. But at the same time, this is not a part that is easy to make. If you look at this, this is the gearbox, or this houses the motor. That's what it is. It houses the motor. It's got like a thin sleeve that holds this black part. Like, it's not an easy part to make. This is it right here.
But can't you put a spacer between the gearbox and that black part right there, rather than?
You can, and that's what I was gonna say too. Then you'd have to like file it down in a different place. Honestly, I recommend redoing the whole thing. Like, why not?
Yeah, we have the time for it, honestly.
I mean, you don't even have to redo it. You just have to modify it. So if you didn't want to redo it, which I would understand, you could. This is something I didn't include in the report, but you could like weld, like plastic weld, basically glue a sleeve at the right height, if that makes sense.
Yeah.
And then that would act as your
The
flange.
spacer is placed inside there that you're saying glued in so it can't move around.
Yeah.
Okay.
Essentially doing the same thing that you would in a redesign, which is adding material.
Yeah.
But all you really need is a ring. So just a flange around where you want it to sit. But yeah, so that's there. Like I said, that's kind of concerning that this guy, but again, if we fix the ceiling, that problem should go away. Which is the shaft kind of sticks out above the spur. Yeah, the missing screw. And then this, you just obviously have to just hold it. You could sink the bearing, the thrust bearing, but I don't know if that's a good idea.
To sink?
Yeah. Yeah, like instead of making a ridge, on the inside of this or the outside of it, you could just put a hole that is this, maybe like a little bit bigger than this, so that it fit inside that hole, like basically a countersink.
Yeah, make a female component so the male can just go right in.
Yeah, that would center it, and I mean, but that would change the height too, so you have to keep that into consideration.
When this was first being built, I was talking to Jose about it. I was actually talking about the other thrust bearing, but he brought up this thrust bearing, so I was like, oh, it's going to move around. And he said as long as it's sandwiched properly or compressed properly, it won't move.
No, totally not true, because the arm, it's like doing this thing. It's like constantly in a sagging position.
Okay, yeah.
So, I mean, unless it was like straight up, then you can argue, well, yeah, because you have to understand it has to move in a concentric path. If
Mm-hmm.
it's sagged, it's not concentric. So it doesn't do its job. Like it doesn't provide reduced friction around a certain diameter because it's not going around that diameter.
Yeah. Okay.
So that is summarized here. Um, it goes all the way up to 5. Yeah. Yep. Oh, also the spline, it's obviously bent. So maybe bending it straight would be a good idea.
Would you be able to show me a picture of the bend, or did you not have one?
I didn't. This is the only. I mean, I'm sure there are more pictures, but not one that. I mean, there might be one. I really don't think so, though.
Is the spline the motor shaft?
Yes, I think
Oh,
so.
yeah. Okay. So that might require a whole new redesign if it's bending the actual shaft, because that's just dangerous.
No, because I think it's bending because of the problem, because it wasn't built. Because
Okay.
those things that we're fixing weren't
So if we fix
fixed.
those, it shouldn't have that issue. Okay.
Yeah. So that's what I'm saying. Like maybe bend it. Um, but like for long term, probably not. Oops.
If it's already slightly bent for
I would bend it back for
competition, I
sure.
would buy a whole new motor. Because if you're
Well,
bending,
it's not the motor shaft. Actually, I don't know. I don't know. But I'm wondering if there's a better way of searching this. I don't think there is. Let's see. I don't think there was a good image of it. I kind of actually noticed it last minute. But yeah, basically, oh wait, we have the yeah, it's not the same shaft, so I wasn't sure. You see what I'm saying?
mm-hmm.
So yeah, I'm not sure. I mean, you could have easily like investigated like with it in front of you, but
Mm-hmm.
I just didn't wasn't my mind wasn't there. But yeah, I would just bend it back, worst case scenario. My guess though is that that's not coming from the motor. My guess is that it's clamped onto the shaft of the motor, but I don't know.
Okay. Go check it out.
Hmm. Yeah. Other than that, everything is pretty much laid out in there. And like there's a bunch of pictures that I took that they're in that link. And also there's this thing that I put up. I called it disassembly reference. And basically it's like a OneNote of a bunch of like pictures of the rover
Mm-hmm.
in different parts. I don't know if you've already taken a look into it,
Yeah, I
but
look.
yeah, it's pretty helpful in terms of like when I work on a car, the worst part is not having the manual because then you don't know what bolts you have to undo or what
Yeah.
C clips to undo. So this is really helpful for that. I mean, obviously, whoever designed it did most of the work. I just took a bunch of pictures. And then I just included some pictures in there that I was kind of using to put the report together. But some of those pictures didn't make it into the report. But other than
Yeah.
that, I mean, everything's there. I try to like highlight stuff so you can see what they're called. But yeah, do you have any questions? I know there's no one else,
Yeah,
but
the other guy left. I don't have any questions. That was really helpful. I think first thing I'm gonna do right now is try to get everyone together to go look at the gripper in person, so we can experience what you've experienced. I really wish I could have been there when you were there, but I just had plans that night, so I wasn't able to.
yeah, no
But yeah,
worries.
we'll start working as soon as possible on getting the those little fixes they were talking about done. With time, I don't want to do anything that's a quick fix. I would like to fix it
Well,
once and be done with it, but just gotta.
I would say that as a permanent solution, yeah, definitely not gluing stuff on there, but I think there is a lot of value in just getting things to work. So like say if Robert wanted to work on being able to improve the joystick feature and he was running it and he just needed something to work, obviously get it to work, you know.
Mhm.
But yeah, if it's something, I mean, like I said, I'm not proposing replacing the materials that are used with with lesser or different materials in general. I'm saying we need to like redesign it or at least improve it.
Mhm.
And whether or not we actually get it printed, machined, or whatever manufactured, that's a different story. But to be honest, I would even argue that you could probably 3D print it with, you know, DIY grade plastics
Yeah.
because I've seen it done in other projects.
Mhm.
So for sure, it's possible, but I think it also depends on how much mass the whole thing is. I really, really think it would be easy to reduce the mass of the rover, of the robotic arm at least. Um, yeah, but not without redesign.
Yeah.
So,
Okay.
but yes, I don't know. Are you interested in tutorials at all?
Depends on what.
Like SolidWorks tutorials? Sorry.
I'm not like, and like me hosting them, I can do that. Me watching them, I think it's pointless.
Oh, really? You're pretty good. You're pretty good
I feel
at.
like I understand it pretty well. Yeah.
Oh, okay. Okay. Well, I mean, I I think well, because there's a lot to SolidWorks.
There is. Yeah.
So I'm wondering if through some of these improvements, there is an opportunity to do some like outreaching slash cross sub team collaboration. So I was thinking about this when I was doing some stuff for electrical, in terms of like using SolidWorks for electrical design. And I figured, hey, you know what? It would be a good idea to, you know, for any given workshop to maybe have some mechanicals participate because then they might learn more about the tools that they're already using.
Yeah.
So what I was wondering is if anybody has ever hosted a SolidWorks electrical design tutorial.
How would that work? I'm kind of confused on how you would do an electrical design tutorial.
Yeah,
Like,
so mhm.
like making like a Raspberry Pi, kind of.
Oh, no, 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 no. No, 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 no. That would be more like a controls thing. What I'm referring to is like because SolidWorks is a program that models a system,
Mm-hmm.
mechanical system, but you can also model electrical systems using the same toolkit that's offered by SolidWorks through the SolidWorks electrical. I don't even know if it's a separate app. You have to click on a different icon
Yeah, it's
to
an
open it.
add-on. I know what you're talking about. I've never used
Yeah.
that before.
You've messed with that before?
No, I've seen it, but I've never messed with it.
Oh, okay, yeah. See, so from the electricals point of view, that would be a good thing to like talk about like during the general meeting to get more not just mechanicals but like other people too. Because um kind of like what we're doing now, redesigning things, it's part of the process.
Mm-hmm.
And SolidWorks is really easy to like helpful to do that. And currently what's kind of being used by like the electrical team slash controls team, pretty much the whole team, is like lucid charts and like physical modeling. And I think SolidWorks would fit really like well with the mechanicals, because mechanicals don't, I wouldn't, I don't know. Not most people don't like to use lucid charts for like electrical design. That, if you think about it, how would you fix things and like update them, kind of like how we're doing right now with one of the parts or a couple of the parts.
Yeah.
Yes. So do you think that maybe introducing this aspect to the, to the team would be a good idea?
Um,
Like a
I feel like
tutorial, you know?
I need to do more research on it before I give an answer about that because I don't know it well enough to be able to be like, oh, this would be really cool to share with them.
Hmm.
And if it's like worth the time, it'd be really awesome. I'm pretty sure everyone else in electrical is similar to you, where they want to be able to know different branches of engineering, not just electrical. So that they would love to be able to play with it a little bit. But I
Hmm.
think it needs to be worth their while to play with it, you know?
Yeah, because Altium works really, really well with SolidWorks Electrical.
Yeah.
Um,
Have you played with SolidWorks electrical at all?
just the other day, when I was looking into it, like a couple of days ago. So it seemed, I mean, it is really easy, but the thing is, if there is no database, like that's the thing, we have a whole rover on SolidWorks,
Yeah.
and I don't think any of it is electrically connected, like in
No.
SolidWorks.
The issue I have with the rover we have on our SolidWorks, like they did a good job designing all the parts, but when they made it everything together to make the assembly, nothing actually moves the way it's supposed to move.
In
So
the
it
I
makes
know,
things complicated.
mhm, in the assembly part.
Yeah, in the assembly.
I know what you're saying, but it would still really be helpful for other parts. Like say the robotic arm, say just the gripper. If you put wires in the model and you can rotate it and see, maybe you can't even rotate it. Maybe you could just see what gauge wire goes where and where
That'd
it
be
sits.
amazing.
That
That'd
would
be
be nice.
yeah.
So that's what I'm aiming for, because I think one of the problems, I don't even know if it's a problem, but I think an easy problem to avoid, and it might be a problem that the rover is having, I don't know, is rooted from just a lack of electrical being in the model. Like here we have a great model. Maybe it's not the best model, but here we have a complete like SolidWorks, digital model of a system, mechanical system, but none of it is modeled, like none of the electrical is modeled. And that ended up being a very big problem going into COVID, because all we had to go off of was non-CAD stuff, which is like
Mhm.
pictures, drawings, and that could have easily been avoided if we had been using SolidWorks electrical.
By
Um,
electrical, what do you mean by that? Just like wiring?
yeah. Like so SolidWorks has this interface where it turns, like you can connect a Raspberry Pi with a connector, wiring harness, and like it's supporting things. So like maybe you can have, your connection lines, your battery lines, all of that in this like a AutoCAD model, which is in SolidWorks electrical. And then whenever you make any change in that electrical model, it updates the mechanical model with a
Mhm.
physical wire that you can move around, you can see, you can,
Yeah, I
you
understand it.
can,
Okay.
yeah. So all it is, it's like modeling software. It's not
Mhm.
like, but it actually is pretty powerful. Apparently you can do like some stuff, like electrical stuff. But like I said, like the main point is just to model. But
Yeah.
you can connect like like an Altium file, PCB, into like the electrical model. So now all of a sudden you have an image of a Raspberry Pi sitting right there. And you can move it around. You can stretch the length of the wire. You can color code the wires. You can, like you can actually model it. So
Yeah. That'd be nice
that
because you know like how what gauge wire
big,
you want to use and how long you want the wires to be, which would
and
be
where
cool.
they're connecting.
Yeah, where they're connecting. I think you can already have that inside of
Oh, really?
solid. We already have our motors, linear actuators, servos inside there, stuff like that. And I'm
Okay.
sure if we can find a linear or a Raspberry Pi or whatever, we can just drop that CAD file into there wherever we want.
Right. Yeah. So that, yeah. So like there's, because what we're talking about is systems engineering. And in systems engineering, it's like how you manage a big project that has multiple systems. And the first part about it is modeling it, kind of like with any design process in general. You need to like use math models, physical models, drawings, cardboard and stuff, and you
Mm-hmm.
just need to model it. Well, with systems engineering, the push, like say Jeff Bezos, Elon Musk, what they did is like invest a lot in SolidWorks, like Altium, those projects, those things to model things. And there's simple reason is because you can update globally. So if if one engineer changes a connector on everyone's end, the person doing the billing, he sees what connectors are being purchased. That's immediately updated in the BOM, the bill of materials. For the electricals, you physically see it. Oh, it's bigger or it's smaller or whatever. But also like say Altium. Altium will know that this length wire is this much more resistant. So so um I think part of the thing that has helped Rover is being able to model things, and that's almost exclusively come from the electrical side or from the mechanical side.
Mm-hmm.
Um, but I think the push should be to model the entire system, including like the finance, which not wouldn't be difficult, but but yeah, it should be done. I think with electrical modeling and mechanical modeling, you can already do a lot, but other types of systems that I don't even know if they exist, but I know that some programs like MATLAB do incorporate some level of computer science, modeling basically. So being able to run scripts with the mechanical models and the electrical models to look at a control system. So, looking into the future, I can imagine the controls side working a lot more with MATLAB, and the electricals working with Altium and SolidWorks electrical, and hopefully the mechanicals would be able to learn about the other parts too. So I guess that's my spiel about modeling software, because it's very powerful. It's pretty nice. And not
Yeah.
only that, employers really look for that.
Mm-hmm.
So, but yeah, I kind of think that tutorials are the way to do it. I don't know. Yeah, you're right. I think a lot of it would just have to be like self-educating each other about how to use these things and helping each other do that. So yeah, if you're interested, maybe we should do a workshop on this, like a video basically, so that we wouldn't have to keep repeating it. That way, it's like what do you call it? Like it just keeps going or whatever.
Yeah, yeah. You want to do a workshop on SolidWorks for electrical?
Yeah, so I'm trying to put together several workshops for electrical, because for
Okay.
like the sub team, and one of them is SolidWorks electrical.
Mm-hmm.
Um, but I think the problem wouldn't be so much learning about it. The problem would be how much mechanical stuff can you teach in electrical, and how much electrical stuff can you teach in mechanical, if you
Yeah.
know what I mean. And that's what I'm trying to push, in a sense, um, because I mean SolidWorks has both of those things, and if mechanicals use SolidWorks and if electricals use SolidWorks, that that has a much higher likelihood of happening, like cross team.
Got you. Yeah. I think it'd be very nice for everyone to know multiple sub teams like that, and that's something that Robert Pace really wants everyone to start doing, especially like mechanical and understanding the control side of things because it makes it a lot easier on them. I think the one thing that would be good for us to focus on before we start having the workshops is to get people motivated and get them to understand why it's important to understand multiple teams.
Yeah.
Right now, like I know a lot of people in mechanical, like they just want to focus on mechanical because that's what they're majored in, you know. They don't really see the benefit in learning about electrical or controls. But when I was talking to Jose a few years ago, like he was saying, like when you're part of the rover team, you need to know at least, or I don't know if it's rover team or just engineering. But he's like you need to be you need to know at least three different divisions. So it could be business, mechanical, electrical, or controls, electrical, mechanical. But you should master or be good at two and master one.
Oh, that's interesting.
That would be very cool to like go check that out and definitely do something with electrical. I know
Yeah.
I tried getting into controls. I started going to controls workshops and stuff, and I got bored really fast and stopped going to them. They were just going right over my head.
Yeah, that's why I'm saying, like, if there was a repository of videos that would help people in terms of what they're motivated and learning to do. Like if you're a mechanical and you want to put wiring on your on the motors of your thing because you want to watch the suspension